So just to review, we want to graph the function y equals x squared plus 2x minus 3. We're going to do that by graphing the zeros, and I'll probably go ahead and find the vertex as well. If you remember, we find the zeros, or x-intercepts, by setting y equal to 0. And since this is a quadratic equation, we could use the quadratic formula, or here we can also factor. So here, I know I need values x and x to get x squared, but I'll also need two numbers that multiply to be -3, but also add to be 2. And so 3 and 1 will work, where the 3 is positive and the 1 is negative, because -1 times 3 is -3, but -1 plus 3 is positive 2. And so then using our zero product property, we can set each of those factors equal to 0. To find that x equals 1 is a solution, because we can add 1 to both sides of the equation there. Subtracting 3 here will give us x equals -3. So those are the zeros, or x-intercepts, of the function. So there's 1 here, 1 here. And that's actually enough to give us a pretty good idea of what the graph will look like. Because it's quadratic, we know the graph will be a parabola. The leading coefficient is positive, it's 1 here, so we know it's going to be concave up, and so it'll look generally like this. If we want to get a better idea, we can graph another couple of points. For instance, the y-intercept is found just by plugging in 0 for x, which would be -3. So right there. And then I always like to find the vertex. And remember, the x-coordinate for the vertex is -b/2a. Which is given by, here, b is 2, so -2 divided by 2 times our a is 1. So just -1. And the y-coordinate we can find by substituting that value of x back into our equation. -1 squared plus 2 times -1 minus 3, which gives us 1 minus 2 minus 3, or -4. So the vertex is at -1, -4. Right here. Now, we could also use symmetry to get another point for free. This one would go right over here. And so we can just kind of connect these dots with a smooth curve and get an idea of what our parabola looks like.